Hello, ladies and gentlemen. Welcome to another episode of the live stream for Without Spot or Blemish Ministry. We are so glad you're here today. Today, we're going to be talking to Jeff, who has a long history in computer science. He's going to talk to us about all the ins and outs of how the networking, the systems are available to lead us into a future where Revelation 13 can actually come to pass. You know, Chad and I talked a lot about that in our last live stream. Doug and Chad talked the future. Now we're going to kind of drill down into how these systems work and how they are ready to go to support such a launching of technological endeavor to make it so that no one can buy or sell without a mark, according to Revelation 13. But before we begin, let's go ahead and pray. Father God, we just praise you and thank you for this opportunity to come before your people. We're asking that no flesh would speak tonight, Father. We want to leave this broadcast different than we started it. We're asking you to intervene and to just teach us, Lord, from your word and from available information and from the knowledge that Jeff has stored up about computer systems and whatnot, that we can actually understand what's happening and we can speak on it and expound on it and help people not to take the mark of the beast when it comes along in full fruition, Lord. We want to help your people to turn away from what the world has to offer and turn to your kingdom. So we just come against any demonic spirits working either through me or Jeff or in this place or even against the listener. We bind up all demonic spirits from interfering with this broadcast, and we loose that only God's Holy Spirit would speak through us, and that only God's Spirit and the truth would be heard by the listener. We bind up any convolution of the message in the listener's ear. We also come against any spirits of fear that would try to come against anyone tonight, and we loose the perfect love of God that casts out fear, and the love of God that gives you power, love, and a sound mind. That's what we loose in each and every one of us. In Jesus' mighty name. Jeff, so glad you're here. Thanks for joining us.
Great to be on again, Doug. Thanks so much for having me tonight.
Well, I just really appreciate it. I know how much you know about these different ways that technology has advanced to a state where things like this are impossible. What used to be, like Star Wars and Star Trek type stuff is now a reality. And I want to actually just show people what the Internet of Things is first before we get going, because this is sort of the basis of the network that's going to tie everything together and make the mark of the beast possible. So I'm going to go ahead and play this video really quick for our listeners.
The Internet of Things, or IoT, is influencing our lifestyle from the way we react to the way we behave. From air conditioners that you can control with your smartphone, to smart cars providing the shortest route, or your smartwatch which is tracking your daily activities. IoT is a giant network of connected devices. These devices gather and share data about how they are used and the environment in which they are operated. It's all done using sensors. Sensors are embedded in every physical device. It can be your mobile phone, electrical appliances, vehicles, barcode sensors, traffic lights, and almost everything that you come across in day-to-day life. These sensors continuously emit data about the working state of the devices. But the important question is, how do they share this huge amount of data, and how do we put this data to our benefit? IoT provides a common platform for all these devices to dump their data, and a common language for all the devices to communicate with each other. Data is emitted from various sensors and sent to IoT platforms securely. IoT platform integrates the collected data from various sources. Further analytics is performed on the data, and valuable information is extracted as per requirement. Finally, the result is shared with other devices for better user experience, automation, and improving efficiencies. Let us look at a scenario where IoT is doing wonders. In an AC manufacturing.
Alrighty, so I just wanted to give you guys that brief little clip that I found on YouTube about the Internet of Things. I thought it was a pretty simple explanation. And Jeff, what's amazing about the Internet of Things is how much it's already in place and how much these sensors are in almost everything that we buy, whether it's computers or phones or dishwashers or refrigerators. And my main question and starting point for you is, Where is all of this data stored, and what does it take to store this much data? Tracking people's movements and video and all of this stuff. How can this much data be stored? How is this even possible?
Yeah, that's a great question, Doug. Most of the devices that we're familiar with and what we call daily consumer tech are mobile devices, things like smartwatches, Fitbit, home thermostat like a Nest, or even our Amazon Alexa and Google Home devices. Those are piping back data almost in real time, in some cases in real time, back to a central server, which is maintained by the manufacturer of the devices. It communicates through a system called an API, which is just an acronym for Application Programming Interface. It's basically a way for your physical hardware to talk to a system that is grabbing and organizing all the data that you're piping back in a two-way communication system. That's stored on servers, which in turn is put into databases that are on the cloud. So by the cloud, we mean not actually on physical local machines, but basically in a virtual space, which is created through large warehouses of servers that are either owned or leased by the manufacturer or the store of the data. So what's made all this possible is just a lot of cheap computing, powerful computing through increasingly powerful hardware that we've all benefited from, being able to have conversations like this on YouTube, over Skype, over WhatsApp, FaceTime, etc. All those conversations are happening virtually over servers, and there have been a number of physical advances in electrical engineering and in hardware to make all this possible. We have come a long way since we had giant supercomputers that filled entire rooms in the 1950s and 60s at Bell Labs at IBM to now, where almost all the functions that were executed by a giant machine like that we've seen in old black and white movies of these supercomputers can be done many times over, just even with our smartphones.
Yeah, it's incredible, the advancements since the beginning with the supercomputers. I remember when I first started in the banking world and database marketing, we were still working not just on desktops or workstations, but they still had, those big tape machines working at the time. And then it was transitioning to desktops. And we had, in our database for all these bank customers, we had two PC size, we called them SCSI drives. And we just thought we were the bomb because we had all this storage and they were only 5 gig each. And most phones now are 64 gig. It's incredible just how much things have changed since 1992 in that situation. But even still, imagining YouTube's warehouses for storing all these videos that have been accumulating since 2007 or 8 when YouTube began, I just can't even begin to imagine how much space that would take up.
Yeah, it's incredible how much it takes up. We're generating terabytes of data each, every single one of us, every day with all the things that we do. Companies like Google and YouTube, which is owned by Google, are able, of course, to support the storage of all of that data because they're able to afford it. They can just buy large servers.
Wow. Well, let's try to, now that we understand what they're able to do because of the fact that storage space is getting ever increasingly smaller. Like we said, we can easily get 64 gigabytes of storage in a phone now. That's not a big deal anymore. But what do you see happening, or what has happened to allow for the fact that they can create an Internet of Things? What's going on in the guts of the programming that allows this to happen?
Yeah, the Internet of Things runs essentially on local devices that are distributed to us, consumers, to people, or to physical locations. It could be malls, like flooring of malls. Of course, the inside of our homes with smart home devices like a Nest and Amazon Alexas. And what's happening is you could think of them as just data vacuums. They have listening devices, they have speakers, they have sensors, they sensors that can detect changes in temperature. Of course, they can detect motion, they're kinetic sensors, and then audio sensors, which are able to detect changes in frequency and, of course, record human voices. All of that is a vacuum, which is put into place. You can think of all of these things as a giant sort of fishing net, that like a canvas that's been spread over the earth to scoop up data wherever those devices are.
Wow.
The computing supports the real-time, I guess you could call it hoovering of that data, and then piping it back to a central server where it gets stored in what we call data warehouses, and then behind the desks of sitting behind desks of these large companies are software engineers and data scientists that are trying to make sense of all that data that we pipe back to train, and we would call it sort of to train and models that are used to predict our behavior, to make smart recommendations, to automate decisions on our behalf. And as consumers, to a large extent, we've benefited from a lot of this because it has taken the burden off of us to make these decisions. We've surrendered a lot of that judgment over to our devices and to the companies that maintain these devices. And the promise that's been made to us in exchange is a simpler life, more convenience, and less heavy lifting in our brains to make decisions. The trade-off is that what I said was that we've surrendered our judgment. So essentially what's happening is we've made a bargain with companies like Google and Facebook and others and large tech companies. This is certainly not to single out just Google and Facebook, Fitbit and Apple and even IBM and even smaller companies that are working on artificial intelligence. We've surrendered our decision making to these companies because the tacit assumption is that we think these companies can probably decide a little bit better for us because they know what to do with the data and we don't.
I mean, that's such a good opportunity to segue to the fact that it seems like Google or Facebook, or it doesn't matter what interface you're using, if you start to type something in the search bar, for example, it'll suggest for you what you're thinking before you've given them any indication you're thinking about it. What is that called, and what is that? How are they predicting what you're going to do next or what you're going to want next? And is it because they've been able to scoop up all this data and they're using this data somehow as a predictive programming type activity?
Yeah, it seems like magic, right? When we go to the search bar and then it auto completes what we wanted to enter into the search bar. The reason why that works is that Google every day is what we call logging and indexing the actual real searches that humans are putting into that search bar. It has the benefit of retaining all that information, and then the way that works, just sort of step by step, is that once it recognizes certain characters are just the letters that you're putting in your search term, and it sees a sequence of certain characters, it reduces the set of all possible search phrases based on the sequence of those characters to just a few. And the more you input, the more it's going to drill down in a funnel to the one that it's most likely to be. And the algorithm will also take into consideration certain things like frequency of that search term. If, say, hundreds, thousands, millions of people have searched for it, it'll take into account the actual time horizon of that. If it's recent, you can, to take something topical, you might see a search for something like nurse videos, COVID-19 or something like that. And that's probably a common search. And the reason why, if you put in, maybe I haven't done this myself, but I suspect if you were to put in nurse videos, you'll probably see an autocomplete of things like dancing and whatever it is that's associated with this sort of phenomenon. The reason why that comes up is that Google's figured out that thousands and thousands, hundreds of thousands of people are searching for this all throughout the day, and it's recent, it's trending, and as a result, it'll return the most relevant results. The way their algorithm works is that it's trained to return to you as a user the most relevant, most timely, and most useful, and also the most frequently searched for results. So that's how that works. And what's actually going on, sort of behind the curtains, there is that the software engineers have trained it's trained this model to recognize those patterns.
Are they listening to us, Jeff? Through Alexa, through Siri, through... Are they logging that information too?
There was a civil lawsuit on Google because the Nest device was listening to the audio recording was on. I think you can search for this. There was a civil lawsuit, and then the CEO of Nest actually admitted that it was an error, that they had enabled listening. So yes, it's absolutely technologically, it's absolutely supported by what's currently available, and it's really just like a design and business decision whether or not it's on. The onus is on us to know what's actually going on when we buy the device. It's sort of a caveat emptor problem, where us as consumers have to be extremely careful in what we allow into our lives and technology.
You know, as you talk, I'm reminded of this movie called Minority Report with Tom Cruise, where he walks into the Gap, and he had his, I don't want to get into a long belabored story about the movie, but his eyes had been changed to another man. It turned out he was Japanese, and when he walked in, the computerized system with a hologram greeted him and said, "Hi, Mr. Nagasaki, welcome again to the Gap. Would you like to get another T-shirt?" And it seems like there's a lot of that going on, where they're determining our spending habits and using even biological information to track us too, with fingerprinting, iris scans, and the like. What that movie literally predicted like 15 years ago. Are you seeing this come to fruition as well?
Yeah, that's a really canonical, very famous example of what's going on in big tech. And that scene was actually inspired, I think it was written by a futurist named Jaron Lanier, who is somebody who is considered sort of a tech dystopian, and he's come out as an advocate against big tech and really trying to get big companies to respect people's privacy. And he wrote that scene as a watch out, this is our scary future. And I think he consulted Philip Dick, who's the original author of the Minority Report. And I think he consulted the screenplay for that scene. That is absolutely happening in the algorithms that are driving the digital ad universe. So what we call ad tech in digital ads, there's a lot of it is based on what we would call a recommender system. And recommenders are things that we all know. We just don't know the name of it. We all probably use them almost every day. Whenever you turn on Netflix, whenever you turn on Hulu or Amazon Prime, we've probably all seen things you might like, or because you like this, you might like this.
Yes.
Actually, a way that's actually a machine learning model that's been trained on your data. And the way that works is really simple. It starts to recognize certain characteristics about the things that you consume, the things that you interact with, and then it runs an algorithm to score based on a score to grab all the things that are similar to the things that you have previously engaged with. So it is sort of spying on your behavior.
Totally.
And to your benefit, it's making recommendations. It's claiming to be making things easier for you, so that way you don't have to search for the things that you want, products or content. Digital advertising works a lot of the same way, where there are mainly 50% of digital advertising spend on part of marketers goes through Google and Facebook. At least 50, it's probably closer to 60. And their algorithms essentially work the same, in that they will track your behavior. It'll look at things like when you're on an e-commerce site, let's just say you're on a shoe site, and it sees that you've browsed over to men's running shoes, and it sees that you clicked on something that was navy, and they see that you clicked on a certain brand, let's say Nike or Adidas or Reebok, and then you added it to cart. That algorithm will log, well, it'll remember that you did that, which is why it seems so creepy that we're getting a lot of the things that it seems like we want, or things that we would buy, because the algorithm is actually memorizing your behavior, and it's been trained to recognize patterns in your brand and your consumption preferences, things that you like to buy, content that you like to engage with, and then it'll extract the content and products that it knows has its in its advertising inventory, and feed it back to you, because the model knows that the probability of you actually clicking on that ad or interacting or making a purchase is higher than somebody else, because of your previous history. That's how the actual advertising system optimizes for spending. So when an Adidas or a Nike or Reebok company is trying to sell ads, it basically goes to a Google or Facebook, and they will say, we want everybody who looked for tennis shoes or running shoes in the last 6 months that lives in 15 zip codes in the northeastern United States and is male between the age of 18 and 35, is single, and lives in a one-bedroom apartment. And surprisingly, companies like Google and Facebook have all of that data, and they're able to filter down that audience for a company like Nike, so that every dollar we spend that goes into digital advertising can be spent wisely on the people that they really want to serve that ad to. So that's the bargain that we've made with a lot of these companies, because we're saying we love to use free tools like Gmail and Google Maps and, of course, Facebook Newsfeed and Instagram and things like that. The bargain that when we click through the agreement, and very few people actually read the whole thing, and you click yes, you're essentially saying, I assign over to you, in perpetuity, a royalty-free license to you look at all the things that I do and serve it back to your customers.
Wow. Oh man. I remember when I first was in database marketing myself at the bank, and that 10 gig of information we had, I thought we knew too much about the customer then. That was 1992. And I knew I could, that my whole job was to identify these little niches of customer base that we would advertise a particular product to. And, we thought we knew a lot, but that was for literally like 10 million customers. So we filled up 10 gig of hard drive for that. And now that number has so exponentially increased down to just little behavioral things that you do on a daily basis. All of it's being logged, cataloged, and able to be accessed again by the marketers. But the real question is, and the problem becomes, when we talk about data security and the security about your life, it's one thing for these advertisers to be looking at a group of people, such as you said, the single 25 to 35-year-old that lives in an apartment by himself. It's one thing to look at that from a high level and identify a whole group of people and not know each person by their name. The problem becomes when governments begin to access that data and build dossiers on us. And I'm not sure it's a question you want to answer, but how do you see all of this data acquisition going? And, of course, different countries treat data differently, but what do you see happening in the world with all this data when it comes to governments and dissidents and dealing with people that the government is cross with?
Yeah, that's a great question, Doug. There is a famous investor and venture capitalist, and now kind of a big public figure. His name is Peter Thiel, who was the first individual investor in Facebook, and later was also the founder of PayPal with Elon Musk. He said recently that AI is short for artificial intelligence, which is the sort of the lifeblood of what big tech is able to do, is communist by nature. I think the
Wow.
reason he said that is that artificial intelligence ultimately optimizes for centralized decision making on behalf of the individual, which basically strips away the choice of the individual and puts into its place a hive mind to think uh, to think for them. And how this happens is that a machine is basically taught, given all of the permutations of choices that an individual can make for a specific decision at one point, given a certain set of constraints. Given these conditions, what is the best decision that you can make? So let's take, for example, should I turn left or should I turn right? We all use probably some mapping software. Um, and what's actually happening is that is actually a machine learning model that Google has trained to make the decision for you. It's already
Wow.
off on your behalf. That way you don't have to read a map and look at traffic conditions and think about whether or not you're going to beat the light at this point and get around.
Can I stop you? I want to ask you, are you
Sure.
saying to me that that information wasn't programmed into the computer by a human to say, okay, if A plus B occurs, then C? It's the machine figuring it out on their own, on its own. It's the software is such that it can learn.
It is learning from user inputs when, especially with so Google Maps will rely a lot on user on annotations, and Waze will also rely on user. So annotate
Oh no, I think I lost you. Are you back?
that.
Okay, we lost you for a second. Can you repeat what you just said?
Okay, can you hear me?
Yep, I can hear you now, but we lost you for about 10 seconds.
Okay, so Waze is another mapping software that relies on contributions from us. So the algorithm will smart update when somebody 20 miles driving ahead of you reports an accident or a police officer nearby.
Right.
The algorithm will instantaneously update and then make a new recommendation based on what others have
I've had that
brought.
happen to me several times and I ignored it and I was at my own peril. But at the same
Yeah,
time I'm thinking, my goodness, they're aggregating data from people that I guess we signed up to volunteer that information, but they know where every person is, they know what's happening, they know how fast they're going. They can determine that, oh, there's a traffic jam there because all 20 of those phones are stopped in place. Something has stopped them. And we can tell the people that are coming from farther back that, hey, you might want to choose another route because this grid of people is not moving. Is that what you're telling me?
that's a great example, Doug. A lot of these algorithms will optimize using things called anomaly detection systems, where, just as you said, this is if you think like a model, the model has observed this is what it normally looks like at 3 p.m. On this intersection on a Sunday afternoon. And it knows that's what it normally looks like because it's observed that hundreds of thousands of times in that location, because it's recording what the traffic reports.
You were really
And
creeping me out because it sounds like we're talking about a person. We're talking about an entity that's observing something.
a lot of artificial intelligence is actually designed to try to think like a person, replicate the cognitive processes of a human being. So going back to the anomaly detection example, it'll recognize when something's off. And it'll say, well, that's strange, Sunday afternoon at 3 p.m. Why is there so much traffic here? And then it will reroute you because it'll recognize this is not normal. So instead of going there on a Sunday afternoon, it'll route you to a different, use a different street or highway. And a lot of that is just recognizing something that's just not fitting to a pattern that it's looked at over time. And a lot of that is actually very similar to how we think about things. So artificial intelligence is actually a system of trying to replicate decision making and judgment that, yeah.
Wow. But, they talk about, I know you probably didn't want to talk about this, but I think about that word singularity. They talk about the fact that there could come a point where all of this artificial intelligence could actually surpass the intelligence of humans. And I mean, we don't even need to go there because this dystopian future that could possibly happen, I personally think Jesus come in and intervene before it gets there. But it's crazy how quickly in the last 5 years, all of this has snowballed into that being a potentiality, that the fact that these computers can begin to learn from each other. I've heard, and Chad brought this up last night, that the whole blockchain and Bitcoin and whatnot, a lot of these programmers are saying that the only way that something like that could have been created is with artificial intelligence.
Yeah, that's right. Although I will say singularity is a pretty controversial topic. So some people say that it's gonna happen very soon because of the learning rate of machines. The speed of learning has gone up so much over the past few decades that it's starting to look like they're achieving a state of sentient beings, which is, that they have self-sufficiency and awareness, kind of, the things that we've seen in movies. I think independent of, whether or not we're getting there, you bring up an interesting point with artificial intelligence, which is basically that artificial intelligence is trying to simulate the real-time instant decisions that we make every day as humans. And the way this works is through a system called classifiers. And a classifier is basically the sort of term that's used in engineering. It's basically an algorithm which is used by a machine to distinguish between potential categories or objects. The most common one that's used is a binary classifier, which is yes or no. It basically is 0 or a 1. The one that we all don't realize is being used on us all the time is particularly by financial institutions and banks. So a bank is going to make an assessment on whether or not you are a good potential debtor for a loan, and it's running a classifier to say whether or not whether you are a risk or not a risk, and that is a decision that it is looking at, and the things that it will look at is like your credit score, your debt to income ratio, your purchase history, other assets, your family situation, spending patterns, etc. And those are all what we call features about every single one of us. And the people that are running these models at banks and credit card companies, they're training a model to recognize whether or not somebody like you or me will default on debt based on all those characteristics.
So it goes way beyond just your credit scores.
You could start predicting other outcomes. In healthcare, it becomes especially controversial because you can use machine learning to try to predict whether or not somebody's going to get cancer, or if somebody is predisposed to a very expensive condition. And this is why insurance and machine learning has become really controversial for regulators, and things like pre-existing conditions are really pointing to whether or not somebody could be, like Minority Report style, just denied healthcare insurance just because of what a model is saying is likely to happen to them based on what it's predicted. Wow. So this is all the dystopian stuff that artificial intelligence can bring in. Some of the more benign examples is just simply like image classification. You can tell, basically, a machine can just start distinguishing whether or not a picture is a dog or a cat, if it's a pizza or if it's a hamburger, a mountain or a lake, farmhouse or a strip mall. And the way you get a model to predict these things is you have to teach it like you would teach a child how to recognize the difference between a dog and a cat. And it can start to distinguish between simple things like, dogs and cats and the sun and the moon. And this process is basically just called learning. And the way this works is if you show enough of one thing to the machine, it starts to recognize consistent features about that object that are recurring and consistent over time and over space. So, for example, a child will recognize that a round shaped fruit, if it's red or green and it's typically in an environment like a kitchen or an orchard, it's most likely going to be an apple. By the same sort of decision process, you're teaching a machine the same thing. You're showing it pictures, and it starts to learn that the pixels are red, the pixels are green in that image with a certain level of density, and usually against the background of a kitchen or orchard. It learns that as a pattern that's associated with an object like an apple. And so this is from the ground up.
I have this image in my head as you talk that like artificial intelligence is on the whole is like an 8-year-old right now, but it's gonna grow in dog years and become older and wiser very, very, very quickly. Is that?
Doug, that's a really, really, really accurate statement. A lot of what people say in the tech business about AI is that AI is still at the level of like toddler-like decision making, and we're we're only set back by the amount of data that it needs to efficiently train a model to start thinking like an adult. So like adults, we learn with experience, and the reason why we're able to make different decisions and more complex decisions as we get older is because we see more things. And machine learning models are the same way. You have to feed them more and more observations and more things so that it learns more complex situations. And that's why things like IoT are really, really big things, big potential drivers of smarter AI, because it's just bringing online that much more exponentially larger volumes of data and higher quality data.
I mean, if it's tracking everyone at
Um,
every level of everything they do all day long, because there's transistors and sensors and everything we own, I mean, the data absorption rate is astronomical. And if AI is able to absorb that and to teach itself with that much data, I mean, the only limitation would be processor speed and ability to analyze all that data.
that's exactly right. Yeah, you nailed it, Doug. That's exactly it. Those are the limitations right now. A data scientist notoriously when they're in the weeds and dealing with large data sets, the biggest problem that they encounter a lot now, especially in computer vision machine learning, which is basically recognizing and processing images and being able to distinguish between different images, is what you would call a sparse matrix. So every single one of us is essentially you can think of us as a matrix, as a data set. We have a row is our ID, and is who we are. And one row could be 1 minute or 1 hour or 1 day if you think of us as a spreadsheet. And then in the columns is all the different things that are about us. Like, so if you just take our apartment or our home, one row is row, and etc. And then columns are what was the temperature, how many people were in the apartment, what was the level of noise, was the TV on or off, etc. So data scientists are dealing with this data set, and one of the bigger problems that they have is missing data, and they can't accurately train a model without a complete data set. And the metrics that data scientists use are things like accuracy rates. So was this machine accurate in predicting that it was an apple or an orange? And in order to improve that accuracy rate, which in turn will give us stronger confidence in the decision-making power of that machine, we need to have more and better data. So data volume and data quality is very, very positively associated with the accuracy of a model, and then in turn our confidence and our ability to surrender our decision making to that model.
Wow. I mean, I just want to let you know that I turned the camera off on my end because we were experiencing a little buffering. So that's why you can't see anymore, Jeff. So please don't worry about that. We can still hear you fine. So my question now, I'm kind of transitioning to the addictive quality of being able to Google search anything you want to know. There is something extremely addictive about that, I think, for people in general. Like for me, I like the fact that if I have a question about anything, I can look it up and I can find it at my fingertips. It's on my phone, it's in my laptop, it's in the tablets, it's wherever, whenever. I can have instant access to that information. And I think that this addiction on the part of humanity has obviously helped feed into the fact that we are giving them all this information because we're getting something in return. We like being know-it-alls. We want to know. We want to have access to all this information. And one thing that I'm noticing, and I want to present to you a video about Elon Musk talking about brain chips. I'm going to go ahead and play that really quick. If you guys will just bear with me.
Well, Elon Musk's next project isn't a car or a spaceship or a solar panel. The executive's latest startup is called Neuralink, which focuses on the goal of implanting chips into human brains and also connecting brains to computers. Here's what Elon Musk said at a conference in California about the technology last night.
This, I think, has a very good purpose, which is to cure important diseases and ultimately to help secure humanity's future as a civilization relative to AI. This, I think, has tremendous potential, and we hope to have this aspirationally in a human patient before the end of next year. So this is not far.
Okay, so you could hear that, Jeff, and I know you've heard this has been in the news. You've heard of this already, but it's just so interesting. I mean, I think about those cochlear implants to help the deaf. They've been around 10, 12, 15 years. And what is it for them to put in some computerized chip in the brain of a person and then cause them to be part of the hive, to literally, not just for medical purposes, but to eventually just have a thought and have a question instead of having to type it into your phone or ask Siri or Alexa. You just think it, and then the data is driven to you through some internalized chip in your brain. Have you seen anything about this?
Yeah, Elon Musk is really at the forefront of brain-computer interface, and I think what we're seeing a lot right now is that probably the closest thing we have to a real commercial application of widespread commercial application of a brain-computer interface. The bigger implication, I think, of that, Doug, on the point that you made, is of course we do things like this, like you said, because it's convenient. We like the power. We like to be able to access something instantly. Very few people actually love reaching down to their phones and having to tap and hold a phone and work through, you know, all the characters to type out a text message. That the next step, of course, you can think of even cell phones as an intermediate step to it just being accessible through our neural interface to some way for us to transmit that information back to the CPU. Without us having to actually touch something with our hands. This, of course, we would do, most people would find attractive because it's convenient. And what actually happens, though, as you said, is that if you're thinking of it from the perspective of Elon Musk's company, Neuralink, you're able to create support systems through something called swarm intelligence. And the basic is that when things work together, like an ant colony or birds in a flock, they're smarter together than they are alone. So you can get an entire fleet of, let's say, if we're looking at robots who have something similar, you can get an entire fleet of robots to act like an ant colony, to perform certain basic tasks all you have to do is assign them simple rules and then say, here are your goals as a fleet of robots. These are the things that are the most important to you. You should prioritize these goals over everything else. And then it'll naturally be set to optimize those goals. And it could be at the expense of whatever else you told it is subordinate to those goals. So basically the idea is that you can get a herd to pursue an optimal behavior better than you would be to try to figure it out on your own. If all the actors in the unit are maximizing that collective goal, it'll select for the best choices from every actor.
This is like the Borg. This is Star Trek the Borg.
Right. Yeah, that's exactly right. That's exactly
the hive
right.
mind, the swarm mind.
It's the hive mind, and there are applications for distributed computing and IoT devices, where every person that has an IoT device like a Fitbit, or maybe even just a physical device like a microchip, planted in their body, is functioning like a node in this bigger system, and then the central system is observing all of the decisions at a given time from all the nodes within that network, and then it's just selecting for the best decisions because it's able to choose from everybody. So you can basically think of it as a way for a collective decision-making system to come to life, because that network has just agreed to work in concert, and then there's an agreement made with the central decision-making system that we're all going to transmit this data back in a two-way system in exchange for the best possible decision. So things like a Neuralink or any kind of brain-computer interface application will get people into the network because it'll promise them convenience and security and smarter decision-making, et cetera. And then in exchange, it is saying, I want a collective decision made on my data and not my own. We already have a preview of a lot of this right now because we don't even realize this in things like Netflix. When Netflix is recommending content to you, it's actually it's searching over the entire data set of content that it has ranked similar to yours because of what other people have looked at that is similar to your content. So when other users are liking a Rambo movie that you liked, it is recommending that that other user's favorite movies to you. So it's essentially crowdsourced. So I think if I haven't totally explained it clearly, let's say I like the same movies, Doug, and it recognizes that three of the movies that you liked, I also clicked 5 stars on Netflix. But there's one that I have liked that you haven't liked, but it falls in the same genre. It may recommend that to you because it has seen that I've liked 3 of those same movies that you have, and so have all these other people.
Amazon Prime does it. The movie, Amazon Prime TV or whatever you want to call it, it literally says to you, well, other people that watch this movie were watching these movies. It tells you like right out, this is what other people that watch this movie, or, when I go on Musician's Friend, other people that bought this product bought this with it. And it suggests like sometimes you actually need this other thing that goes with the original thing you're buying. You're not realizing, well, I might need another part. And there'll be a suggestion at the bottom that literally says, other people bought this with that. And then you're like, sometimes it actually prompts you that, oh, I actually do need that. And it's crazy. I've seen what you're describing a lot on all the places where I buy things.
Yeah, that's exactly right. So that's a very light version of what could be coming in the future across many other applications. It's easier to do a recommender system on this kind of closed system like products and movie content because you're looking at a fairly homogeneous set of data that's fixed.
Right.
But machines start to learn over different conditions. A good example is a self-driving car, and the reason why self-driving cars are taking a lot longer to get to market than other things is that it has to learn all these, at any given time, there's so many variables it has to process. Sunlight, how many pedestrians are in a crosswalk? Is there fog? Is there a biker coming across in the other lane, or is there a biker in the wrong lane? Just in all these variables. And then it's computing in real-time probabilities that something's going to happen if you make decision X, Y, or Z.
Well, a lot of these cars, they're not fully self-drivable yet, but they will stop you from pulling into a lane that's occupied and whatnot. I mean, they are slowly adjusting to that. And I'm thinking as you're talking, if people are willing to give over the car driving them or put a chip in their brain, it's going to be a very short walk to accepting a chip in your right hand or your forehead. That's actually not going to be that big a deal technologically speaking compared to these other things that we're describing.
That's right. That's right.
It almost will seem, I think when it happens, it would almost seem no big deal. In fact, let's go ahead and show this video of what's been going on in Sweden in this regard. And I'm gonna show this video real quick, and we'll be right back with Jeff. And I can't tell how much I appreciate this. I feel like I'm getting an education, like I should pay for this. It's been amazing. But I'm gonna go ahead and play this, and then we'll transition to this topic. Okay, here we go.
When Elias Brotberger goes to work, he doesn't need ID, and he doesn't need money. In fact, much of what he needs to get through the day is hidden right there, just below the surface, in his hand.
You like to touch it?
Yeah.
Yeah?
Oh, weird. Yeah, it's like a grain of rice.
Yeah, a grain of rice.
Embedded in his hand is a microchip that serves as his keys, his ID, and his wallet.
Yeah, it's all in chip, so I use it like to get around the building.
Buy snacks.
Yeah, exactly.
Let's buy some snacks. Exactly. So I can't open it.
No.
Okay.
So what I need to do is I need to first blip my chip, and it will log me in, and from there I get access to the fridge.
Popular TV shows like Black Mirror have imagined chips as part of a dystopian future.
Install in-grain procedure with local anesthetic and you're good to go.
In Sweden, the microchips are already here.
The microchip implants use the same technology that's in contactless credit cards,
which have made cash pretty much obsolete in Sweden.
No cash.
At this tech fair, a chipping event for those on the cutting edge, merging their hands with this new technology.
I thought it would be fun, right?
The process is simple and swift. A pinch of the skin, and in a matter of seconds, the chip is inserted. The transformation is complete. As for the pain,
I barely felt it.
But even in this nation of early adopters, not everyone is racing to get chipped.
Feel less human. I will feel like a robot.
I think, so much more data can go into this, when it's in your body.
There's no central registry tracking how many people are chipped, but biohacker Hannes Wellblood estimates between 5,000 and 10,000.
In the future, do you think everyone is going to be chipped?
I think it'll be voluntary, but I am certainly convinced that millions of people will find it very, very valuable to have a smart device under their skin.
Human microchipping may be our future, but in Sweden, it's already reality. Sarah Harmon, NBC News, Stockholm.
Hey, NBC.
Wow, Jeff, that's just unbelievable. That it's just, I think in a society that's more prone to atheism and no understanding of scripture, why would they have any pause or any hesitation if the Bible's not believed or not even respected, or if it's just they're all gathering dust? Why would they hesitate? It does seem more convenient.
Yeah, that's absolutely right. And it just reminds me of scripture in Revelation 13, no man being able to buy or sell. And when we actually look at the literal application in biometrics, the problem that tech industry is trying to solve with something like a chip or any kind of device that you just embed on the actual physical person is how do I move to the next generation of authenticating a user's identity? Similar to what we do when we put our fingerprint in on our phone, or when our phone is scanning our retina. It's basically a way of saying, how do I verify somebody's identity without using passwords and codes and ID numbers and secret answers to secret questions? And we all have this experience. So biometrics as an industry application is trying to encode into hardware a unique biological footprint, or a set of unique things about you as a person that are only specific to you, that can't be spoofed, that can't be hacked, that can't be made up, and that's absolutely unequivocally sure that the person who is logging in is exactly that person who they say they are. So basically, to do that, it would tap into all things that are actually as close to your gene representation or your phenotype representation, things that are biological, rather than purely computational, to stop the problem of a false identity. So it makes it that much easier to authenticate a user when print or an iris scan or an EKG, which is an electrocardiogram, your pulse, of course. And the idea is to get physical hardware to take an instant read on any one of these things that maps you as a unique person to your identity.
I want to interject a comment from one of the listeners. He says, Salty Dog says, it could be a tattoo in some form of tech we don't know about yet. Not wise to box yourself into prophecy as this or that. Like, I guess he's trying to say that to me, he's like, don't just think it could possibly be a chip. It could be other things at the point where it's forced on us. The chip could just be the first iteration of some other technology. That's a good point.
Yeah, I absolutely agree with that. Thank you for that comment. I do try to be very cautious about trying to link an actual physical device to what is actually said in prophecy. Totally, it could be in any number of things that are on the physical person. It doesn't necessarily have to be a chip.
But this chip right now is definitely a first iteration. I mean, for sure. I would not take it. I consider it the mark, to be honest with you, right now, even though there's no antichrist and worldwide power right now to force us to take it. I think people are voluntarily taking the mark. I wonder if those people in Sweden that have already taken it, or those people up in Wisconsin at that food services company that took it, I wonder if they've taken the mark. You know, I mean, but at this moment, it's not that they can't buy or sell without that chip that they've taken, but dang, it's too close. I wouldn't risk it myself.
Yeah, anything that is actually some kind of serious modification of the flesh, I think it's generally sound to say this is something that is going to lead to more harm than good. And anything that could turn you essentially into a node, into a network, could be very bad for you.
I want to show you guys a video now of Pat Robertson basically trying to blow off the chip. He's basically implying you could take it. It's no big deal. You got to see it to believe it. And because I believe he's a Mason and a shill and a Satanist, it doesn't surprise me in the least. But I'd love for the listeners to see it really quick. Here we go.
This is Bob, who says, does a microchip implanted in the body represent the mark of the beast? My wife thinks so and says she would die before letting someone implant one in her body. But I think she's wrong.
Well, it depends on what kind of a microchip it is. Look, I've got in my chest right here a little box. It's called a pacemaker, and it sends the right signal to keep my heart from being in AFib. And it's a nice thing to have. So that ain't the mark of the beast, that is a pacemaker. So, I mean, but the mark of the beast is you're giving your head or your hand, your volition and your action unto this, Antichrist. That's the mark of the beast. And I don't think a little microchip is what we're talking about. All right.
Do you have questions?
I mean, for me, the point's well taken. The guy has a pacemaker. There's probably some chip technology in there. But to me, he's throwing apples and oranges together and mixing up two things. If there is a chip that you put under your skin with which to do commerce, and eventually could be such a thing that you cannot buy or sell without, why would he even introduce that as a possibility to take it? And I think a lot of these Masonic, satanic ministers are going to be trying to get all of their flocks, their betrayers, their Judases. They're going to try to get all their flocks to take the mark. And they're the ones that teach pre-trib rapture too, that we wouldn't even be here. That's not the Antichrist. Take the mark. It's okay. Can't be him. We're going to be gone anyway.
Yeah, I think as believers, be vigilant as possible, trying to reject sort of the ways of the world, and anything that starts to look like that this is what the world is doing to make life easier. We should be especially cautious.
It's just too close for comfort, and he's acting so flippant about it. It troubles me. It's just really ridiculous. Well, I guess concluding, I'm going to call you an expert. In your expert opinion, we're well past the point of meeting or being able to actually perform the Revelation 13 can't buy or sell without the mark. In terms of data acquisition, data processing, the ability to process people's movements and purchases with this chip or whatever it's going to be, as Salty Dog pointed out, if they're tracking every single object that has sensors in it, like we said, refrigerators, heating and air conditioner units, all the things in the home, in the car, Tesla has an electric car that's surely going to be self-driving at some point. If they're able to track all that, is it even difficult at all to bring Revelation 13 to fruition at this point?
Yeah, I see that the technological sophistication is already widespread and available and commercialized. The level of actual, the level of heavy lifting that needs to be done to make that a reality is already done, and I don't see how.
Look how they created the phone swipe process, that when you go up to the gas tank now, you don't necessarily even have to get your card out. You can just swipe your phone across it. So any interface, retail interface that has that in it is going to be able, I'm sure, to read the RFID chip in your hand if you take one.
Yeah, and if there's any strong enough commercial reason or security, it could be security, health, or even just convenience to actually make that a commercial reality for everybody, it can be done. It can be done in one generation of devices by any number of these manufacturers.
Amanda, a commenter, says the last step is to finish conditioning the minds, I guess, to destroy resistance. Maybe that's what all of this is about right now. They're leading up to it to destroy the resistance. That's such a good point.
Yeah. Fear is very, very powerful. Fear and uncertainty, and a constantly changing bogey is very powerful in getting people to do things they wouldn't do otherwise.
Right. Well, Jeff, man, great job tonight. I thoroughly have enjoyed this time to just go through just all the information you presented. You drilled down really deep in such a way that we could understand it. And if not, we can go back and listen again. And a lot of us have varying degrees of understanding of technology. But I think for some reason, I felt it was really important that we do this kind of exercise as a means of just saying it is possible right now to go ahead and initiate this worldwide. I mean, there's definitely other things that need to be done, like the scanning devices need to be at every point of purchase and all those sorts of things, for sure. All of that still could be done, but like you said, in one generation that could be accomplished, and it's just amazing how far things have come in such a short amount of time. I mean, just thinking back to like 2010, 2012, it seems like we've come light years since that point in terms of technology, and I can't imagine what the next few years will bring. Is there anything you want to conclude with?
No, just want to say thank you for having me on. I really enjoyed it. It was a pleasure speaking, and I'm sure I'll have some more thoughts to share again at some point in the future.
Absolutely. I'd love for you to come back on and we can do this again. So thanks, Jeff, so much for joining us, and I hope everybody got a lot out of it. I sure did. And we will see everyone on the next live stream for Without Spot or Blemish Ministry. Oh, by the way, if you want free music, you can go to our Reverb Nation link that will be below. If you would like to see our blog spot, it's a link below, withoutspotterblemish.blogspot.com. If you would like to donate, you can do so at the PayPal link below. Our handle there is our email, withoutspot@gmail.com. Email us with your praise requests, your prayer reports, and your praise requests. We'd love to hear from you, and we will see you on the next live stream for Without Spot or Blemish Ministry.